Let's do the first question here. This is our galvanic cell. The zinc and the copper electrodes are connected, and this is how we represent actually a galvanic cell. The two vertical lines here represent the salt bridge, and we know to the left side of the salt bridge we always represent an anode, and to the right side of it is a cathode. And that means zinc is anode and the copper is cathode in this galvanic cell. And the anode is the electrode where oxidation takes place, where the electrons are lost, right? So in anode actually the zinc metal will change into the zinc ions, while as in the cathode, which is a reduction, that means the gain of electron will be there, so that means the copper ions will convert into the copper metal. And by convention, we know that the electrode where oxidation takes place is called anode, and it's given as a negative sign, right? It's represented by the negative sign, and the cathode is the electrode where the reduction takes place, and it's given the positive sign. So the negative terminal is the anode, which here is the zinc. So this is the option 3. Which one of the following reactions occurs at the cathode? And as I said, the cathode is the electrode where reduction takes place. So at the cathode, it is the reduction, the gain of electron that takes place. So if you look at here, this first reaction, this is oxidation, loss of electron. This is also oxidation. This one is also oxidation. And here this reaction is the gain of electron. The copper ion gains the 2 electrons, so this is reduction. So that means the option D is the correct option for this one. So the third question is the reaction taking place at the anode. As I said, anode is the electrode where oxidation takes place, where there is loss of electron, right? And it's also as given the negative sign. So that means in this question we can say the option C is the right answer. Now the question number 4, which one of the following reactions is possible at the anode? So at anode, oxidation will take place, the loss of electron will take place. So the loss of electron, and so you can say here, look at this the B, it is the gain of electron. And here the chromium, if you look at the option A, the chromium 3 plus sign, over here it changed into the chromium plus 6. If you look at the oxidation number of the chromium, that is plus 6, the chromium, it changes from plus 3 to plus 6, which means that this is the increase in the oxidation number. So when we have a chromium, its oxidation number changes from plus 3 to plus 6. So which means that this is the increase in the oxidation number. Increase in oxidation number is oxidation, because when there is loss of electron, the oxidation number will increase. And so therefore we can see the anode here, the anode reaction is this one, okay, the option A, because this is the oxidation. This one is reduction. Here you can see the there is a gain of electron, and this is the decrease in the oxidation number from 0 to -1. And oxygen over here is 0, and you can see here it is this one is actually the -2, right? So this is not an oxidation, and we can say here this is the option here, this is the reaction which will take place at the anode. Question number 5, in the copper and the silver ion reaction, the reduction half reaction is, so you can see here, this is the oxidation and this is the reduction, right? This is the reduction, this is oxidation, and this is the reduction. This is the electrode which is called as an anode, and this is the electrode which is called as cathode. And the reduction half reaction will be the gain of electron. The silver ion will accept electron and form the metallic silver. So the option C is the correct option here, right? And now let's take one more question. The electrochemical cell stops working after some time. Yeah, we know that when you look at electrochemical cell, a galvanic cell, and there is some oxidation, there is some difference in the reduction potentials of the cathode and the anode, and the EMF of the cell is actually the difference in the reduction potentials. Reduction potential of the cathode is much more, it's higher than the reduction potential of the anode. And this difference, in the reduction potential of the anode and the cathode is what we call as an EMF. So if you have a cell, we have a galvanic cell, and let's say this is our reduction potentials. Obviously the cathode has a higher reduction potential than the anode. And with time, what happens? The reduction potential of the cathode decreases and that of the anode will increase. And we know that a point will reach in a cell when the difference in the reduction potentials will be 0, and then after that, the cell will not produce current, right? This will be the equilibrium position, right? This will be the equilibrium position. After that, there is no more cell reaction, no more redox reaction that can take place in the galvanic cell. So we can say the electrochemical cell stops working after some time, because then the electrode potentials will be the same, right? You can see the option A, it says that electrode potential of both electrodes becomes 0. No, it's not correct. Electrode potential of both electrodes becomes equal. That is the correct one, right? Because the EMF, as I said, is the difference in the reduction potentials, right? The current will be produced only when you have a positive EMF, right? When you have the EMF, that means the electrode potential of the cathode should be higher than the electrode potential of the anode. This is the option when you can have a positive EMF. The positive, this you can have if the electrode potential of the cathode and the anode is same, then the EMF will be 0, no more current will be produced, right? And if the we have the electrode which has we have a cathode with a lower reduction potential than the anode, then we can say the EMF of that cell will be negative. In that also case, we can say the cell reaction does not take place. It will not be a spontaneous process. So over here in this case, we can say that the electrochemical cell works stops working after some time, because the electrode potential of both electrodes becomes equal, right? So the option B is here. Now the question number 7, which one of the following statements is incorrect regarding an electrochemical cell, right? We have to check which one is incorrect. The electrode on which the oxidation takes place is called anode, right? That is correct, and is always given as a negative sign, right? It's assigned a negative sign. So anode is the negative pole. This is also correct, and the direction of the current is same as that of the flow of the electrons. That's the that is the wrong one, right? I think this is the incorrect statement. Why? Because the flow of electrons. If this is the flow of electrons, the direction of the current will be opposite to the direction of the flow of electrons. The question number 8, which one of the following statement is correct? So we have to check the correct statement. In an electrochemical cell, the free energy of the system decreases, while in an electrolytic cell it increases. So it says the electrochemical cell, that means the galvanic cell, you can say the free energy of the system decreases, while an electrolytic cell, where electrolysis takes place, it increases. That is correct one. We have a cell reaction, the galvanic cell, which is a spontaneous process, and we know for all the spontaneous processes the delta G is negative, right? The delta G is negative, that means the delta G decreases there. That's how the process is spontaneous. In an electrolytic cell, what type of reaction takes place? When you see electrolysis that is being carried out in an electrolytic cell, electrolysis is not a spontaneous process. We need electric current, we need electrical energy to carry out a spontaneous, to carry out the electrolysis. Like suppose you will do the electrolysis of the water into the hydrogen gas and the oxygen gas. This process is not spontaneous, right? This is not possible unless we don't use the electric current here. Unless you don't use the electrical energy here. So it is the electrical energy that converts the water into the hydrogen and the oxygen. So dissociation of this water molecule is only possible by using the electrical energy. Otherwise the process is not spontaneous. And here, this reaction we can use later on in the fuel cells to produce the current. So in this case, actually, in any electrolytic cell, wherever you see the electrolysis, in that case, the electrical energy is being converted into the chemical energy, which means the free energy of the system increases. That means the delta G is positive for the reaction. So that means the option A is correct of a statement here. Now next one is the cell reaction for the cell, zinc and the cadmium is given. So we know that this is our salt bridge, okay, the two vertical line salt bridge, and to the right side it is the anode, and to the right, to the left side is anode, and to the right side of it is cathode here, right? This is our cathode here, this is our anode. So zinc will be oxidized, right? So that means the reaction, this one reaction, the reaction that takes place at the anode will be the zinc will be converted into the zinc ions here, the zinc 2+ and the 2 electrons. And this is the reaction which takes place at the anode, and at the cathode the reaction takes place is the cadmium 2+ ion will gain the 2 electrons and it will form the cadmium, right? So that means this is the reduction, half reaction, and when you join the two, it will be the zinc, being converted into the zinc ion, oxidation. This is the oxidation half reaction, and the cadmium ions being converted into the cadmium. So the option D will be the answer for this question. Now the question number 11. The reduction potential of the two half cell reactions are, we are given the reduction potentials. This is the reduction potential of the lead 2 plus is being converted into the this is the lead metal, the silver ion into the silver. The feasible reaction will be, okay, so we can see here these are the two reduction potentials, and the reduction potential of the silver is higher, so that means this should act as a cathode and this will be the anode, right? Because you can see here this is the reduction potential of the cathode, the silver, which is 0.8, and that of the reduction potential of the lead is minus 0.31. so which means that this is lower, the reduction potential is lower, and this is the higher reduction potential. And we know the EMF of the cell, you can have a positive EMF, you can have a cell current only when the cathode has high reduction potential and than the anode. So that means the silver will gain electron, so the reaction will be the silver will gain electron form the metallic silver, while as the lead metallic lead will change into the lead 2 plus ion. So that means, which means the lead will convert into the lead 2 plus ion, lead sulfate, right? It will be this one. The lead will change into the lead 2 plus ion. The silver ion will change into the metallic silver. So I think the option A is the correct option, because this is the oxidation reaction and this will be the reduction half reaction. Okay, this is the oxidation, this is the reduction half reaction. And over here you can see that this is not the correct one, because you see the lead also being converted from 2 plus to 0 reduction, and this is also reduction here, not correct. So lead to the lead 2 plus, this is oxidation, that one is correct, and silver to the silver ion, this is also oxidation. So again this is not correct one, right? This is not the correct one. And you can see here the lead 2 plus into the lead, this is reduction. So again this is wrong, this is not possible. So silver to silver ion, again this is not possible. So this reaction will be non-spontaneous, because the EMF in this case will be negative for this one, right? If you check this cell and you check its EMF, it will be negative, so which is not possible. So the option A. Other question number 12. If the salt bridge is removed suddenly from a working cell, the voltage drops to 0, right? It will drop to 0. The cell difference, the electrode potential differences will become 0. So which of the following represents a standard hydrogen electrode? We know the standard hydrogen electrode, we have the hydrogen gas. We pass the hydrogen gas through a 1 molar solution, 1 molar HCl solution, and we use the hydrogen gas there, and we pass it through this through the system here. 1 atmospheric pressure hydrogen gas we take, and we use the platinum wire to make the electrical connectivity. So which means that it is the platinum which we use as an anode metal for the electrical connectivity. Then we have a hydrogen and the H plus ion, and these are the concentrations and the pressure at temperature 298 Kelvin. So option A is correct option. The standard potentials at 25 degrees Celsius for the following half reactions are given. So we have the reduction potential of, this is the reduction potential, the gain of electron, reduction potential of the zinc and the magnesium. It says that when zinc dust is added to the solution of the magnesium chloride, so that which means that if you have the magnesium ions, Mg2 plus ions, we have magnesium chloride, so which is MgCl2. So Mg2 plus ions, when you add the zinc, the metallic zinc, so can the reaction take place between these two? Can zinc lose electrons and can the magnesium gain? We have to actually check this reaction. Okay, if this is possible or not. Can zinc lose electrons and the magnesium will gain? Is this possible to convert the magnesium 2 plus ion into the magnesium by the gain of electrons, and the zinc into the zinc 2 plus ion? So that means the zinc will undergo the oxidation, will act as an anode, and the magnesium will gain the electron, so it will act as cathode. So if you check its EMF, then for this type of a reaction, if this is possible, then in this case zinc acts as an magnesium acts as cathode and the zinc anode. So we know the reduction potential of the cathode minus anode, E cathode minus E anode, right? This is the EMF. So we can check this, we can check the EMF of this cell, and that will tell us, the final answer will tell us whether this is possible or not, right? So if you have the reduction potential of the cathode, which is magnesium, which is minus 2.37, and then we have the reduction potential of the this zinc, which is minus 0.76, so 762. So if you check, then this will be minus 2.37 plus 0.762. So if you find this answer, it will be in the negative value. You can see this is minus 2.37 plus 0.76. So it will be minus 1 point something, right? 1 point something. But that means the EMF is negative. So negative EMF means that this reaction will not take place. This is not spontaneous, correct? It's not going to happen. The EMF, the cell will produce current only when the EMF of the cell is positive. If the EMF of the cell is negative or zero, the reaction will not take place. The process is not spontaneous, correct? So that means the zinc will not lose electron and the magnesium will not gain electron. So that means that in this case we can say the magnesium ion cannot take the electrons from the zinc, right? So the reaction is not possible, because we know that EMF of the cell, the cell will produce current. The reaction is only possible when you have a positive EMF, which means that the reduction potential of the cathode, E cathode, should be higher than the E anode, right? The reduction potential of the anode, this is the case, right? The cathode should have the higher reduction potential than the anode, only then the reaction can take place. In this case, you can see the reduction potential of this cathode, here the zinc and the magnesium is that minus 2.37 and minus 0.76 is that of the zinc. So this is not possible, correct? The reverse will be possible. If you take the magnesium metal, put it in the zinc ion solution, so that reaction is possible, but not this one.